this video, you will learn how to solve rates of change questions and how to find a quantity's small change. Hello everyone and welcome to Mathematics, where this channel is able to help you to build up your habit in completing a question a day in mathematics. So for today's video, we'll look at a question from Form 5 Chapter 2, Differentiation. So before we begin, you can take a look and try it by yourself first. So here we can highlight that the round water flask has a radius of 10 cm, and when water is poured into this flask, the height of the water increases at the rate of 0.5 cm per second. So by looking at part A, they're telling us to find the surface area of the water, which is this. So since this is a circle, we can actually calculate using pi r squared. However, our equation and the question's equation is different because the question has h but we have r. So we need to find a relationship between r and h to replace our r with h. So what we can do is we can use this circle's shape to help us find the relationship. Alright, so here will be our circle, and there's a center, and for r represents the radius of the surface area of the water, which is here. It's not the radius of the round water flask. Okay, so take note. So to find the relationship, we can actually form a right angle triangle in this circle and use Pythagoras theorem to form the equation. So our right angle triangle will be here, and we just have to find the lengths of these two sides, which is easy to find because this length is a radius, so it will be 10, and since here is also 10 because it's a radius, so the small part here will be h minus 10, and we can use Pythagoras theorem to form the equation. And let's rearrange this equation to let r as the subject, and we will sub r squared, and with that we have obtained the question's equation. Let's move on to part B. So we need to find the rate of change of the water surface area when the depth is 12 cm or the h, and we need to make sure our answer has the pi. So the rate of change of the water surface area, we can express this as dA over dt, which actually involves the third application in differentiation. So to find dA over dt, we need to use the chain rule to split this fraction. So to fill in these blank spaces, we need to find an unknown which is not in this equation but in the question. So actually we can use either h or r. But which one to choose, we need to look at which unknown has a relationship with a. So if you look at part A's equation, you can see that a and h has a relationship. So we can just put dh here. Reason is because if we want to find dA over dH, we can just differentiate this equation to get. So when differentiating, remember to separate the equation using positive and negative. So differentiating this, you will obtain 20 pi by removing the h, and for here we need to multiply the power and the number to get 2 pi and power minus 1. And for dH over dt is actually one of the things we highlighted just now, which is this. So dH over dt equals to 0.5. Here, remember for the h to substitute the original value, which is 12 in this case. And this answer means for every second, the surface area of the water decreases negative 2 pi cm squared. And for part C, it says that when h equals to 12 cm, there is a small change in h by p%. So using differentiation, we need to find the small change of the water surface area A in terms of p and pi. So here it uses the fourth application in differentiation, which is small values and approximation. So to find the small change, we can actually use this equation. But since we are finding the small change of A, so I'll replace all the y's to A, And for h, I'll replace an unknown which is related to a, which is h in this case. So now we need to find two things, dA over dH and delta h. So dA over dH, we actually found it in part B, which is this. And we need to sub the original value of h. So in this question, it says h equals to 12. And for delta h, we can actually find from this sentence using an equation, which is the percentage change of h can be calculated when we find the small change in h divided by the original value of h multiplied by 100. So now we have the information for percentage change and h, and we can just find the delta h. And we can sub it into this equation. And delta A equals to negative 12 over 25 p pi cm squared. And with that, we have completed this question. So the take home point for this video is when it comes to rate of change questions, we need to use the chain rule to split this fraction into two parts. And for the blank spaces, we need to find an unknown which is not in the equation but in the question. And we need to make sure that unknown is related to y. So for example here, to find the unknown which is related to a, we look at the equation in part A, where we saw a and h has a relationship, so we chose h instead of r. And for dx over dt will be given in the question, but dy over dx need to be differentiated to obtain. And when it comes to finding relationship in unknowns, we can use two shapes, either it's cone or sphere, which is in our case. So both of them need to find the triangle, and for cone we need to find a ratio, and sphere we need to use the Pythagoras theorem to form the equation. And for small changes and approximation, we have three equations. So to find delta y, we need to consider dy over dx, which we need to differentiate to obtain, and delta x, which sometimes are given, sometimes we need to use the second equation to find, which is the percentage change of x. So to find percentage change, we need to use the change of x divided by the original value of x and multiply 100. And lastly, to find the approximate value of y, we need to add up the original value and the small change. Alright, so if you are interested in this questions answer scheme, you can click the link in the video description, and you feel this video is beneficial to you, please give a like, subscribe, and share it to your friends and classmates. So I'll see you very soon in the next video. Thank you.